Okay, this is a quick video to kind of show you how to go from a graph to an equation. So the important part here is knowing where all of your components come from. So for instance, we have two vertical asymptotes here. All right, one right there, one right there. This one happens at x is equal to -2. This one happens at x is equal to 3. Right, because it's just a vertical line that goes through each one of those. So vertical asymptotes come from the denominator. This one's actually supposed to be an open circle. We'll talk about that in a second. Anyway, so the vertical asymptotes come from the denominator. So when I'm looking at my equation, you're just going to put those things into the denominator here. So, right, here's my denominator. Make sure you change it back into a factor, which means you have to move that -2 to the left. So you get x plus 2, and you get x minus 3. Okay, so those would be your vertical asymptotes, and they go into the denominator. Now, anytime you have a whole, such as this, the whole goes into top and bottom. So I'll do the whole here in green. So this whole happens at 1, 2, 3, 4. So x is equal to -4 is a whole. Okay, so again, change it to a factor, and it goes in both top and bottom. So x plus 4 goes into the top and the bottom. Okay, your other x-intercepts are going to go into the numerator here. All right, so when you're looking at your x-intercepts, I have one at 0 and I have one at 2. Okay, so x equals 0 and x equals 2 are two of my x-intercepts. The x-intercepts go into the numerator. All right, so x equals 0. If you move the 0 over, it's still just an x, so it's just an x. And then this becomes an x minus 2. Again, you have to set those things equal to 0 and solve. Not set it equal to 0 and solve. You want to move it over so that it's equal to 0, because that's what the factor would be. So you get that right there. Now, the last thing that you have to do is make sure that the ratio, because here I've got a horizontal asymptote at y equals 1. Okay, so if you remember, the horizontal asymptotes come from when the degree of top and bottom are exactly the same, which here they would be, because if I multiplied out the front terms, x times x times x, I get x cubed. X times x times x, I get x cubed. So since it's at 1 right there, that means that the ratio of the coefficients up here need to be 1. Okay, so for in this particular case, 1 divided by 1 is 1. Just for... Well, I'll do that on the next one. So if it was, say, at 2, if this was at y equals 2, then I would need to put a 2 here next to the x so that the coefficient would be at 2. I should have done that, but I didn't. But that's generally what you're looking at for those. That's the general idea behind all of them. So even if it doesn't have intercepts, it can kind of do the same thing. So let's just say I have one... I'll draw another one out here. So let's say that it looks like this, and this time we've got an asymptote on this particular line. Let's say I have a vertical asymptote at -1. Just to make things complicated, we'll put one over here at 2. Okay, and we'll do a y-intercept of, I don't know, -3 sounds great. So this particular piece will do something like this. Okay, and then we'll have this piece here. And I'm just making up a graph right now. 100% just making it up at the moment. Okay, so again, same sort of idea. So I'll start with vertical asymptotes, and make sure you can actually see. You can, okay. So I'll start with vertical asymptotes. I have one at x equals -1, and one at x is equal to 2. So I put those in the denominator. X minus 1 and x, oops, sorry, that was -1. So this should be +1, and then x minus 2, right? So then when I'm looking at those, so I've got those two particular pieces. I have a horizontal asymptote here at 0, which tells me that the degree on top is going to be smaller than the degree on bottom. I also know that I have a y-intercept at -3. So when x is 0, y should be -3 is going to be something we have to look at. We don't have any zeros to worry about, so I don't have any of those. I don't have any holes. So I have to have something in the top. I just don't know what that something is. So I could potentially have just some number that's up there that we don't really necessarily know. And the way that we figure out what that number is going to be is that we're going to, let me just say, we know that it's not a variable, because if it was a variable up here, then there should be an x-intercept somewhere. So since I don't have an x-intercept, I don't have a variable up here. So I know it's going to be just some number, and that number needs to make this right here true, 0, -3 true. So when I plug in 0, I should get -3. So we're going to set that up, because this is technically equal to f of x, right, which is just your y. So I'll take -3, and I'll set it equal to a over, and I'll plug a 0 in for these x's. So 0 + 1, 0 - 2. Right, solving that out, that would give me a over 1 times -2. Right, so this would give me -2 on bottom. So I'll multiply by -2 to both sides. And you get a is equal to +6. So the equation here, you just take that 6 and plug that in, and this would be the equation for that. And it would have vertical asymptotes at -1 and +2. And then it would have a 0 horizontal, because the degree on top is smaller than the degree on bottom. And then this would give me a y-intercept of 0, -3. So this equation right here would work for that particular graph. So it's just a matter of knowing where to get these components from and where to put them back into. Okay. Again, going back here, because it's got all the pieces, vertical asymptotes on bottom, whole goes top and bottom, x-intercepts go on top. Okay, and then the last thing is to make sure that the ratio works out. If it's the same degree top and bottom, the ratio needs to work out so that you have the correct horizontal asymptote. And then for this particular one, since we didn't have our horizontal asymptote was at 0, we have to make sure that that y-intercept is in the appropriate place. Okay, and you can actually do that on this one too, is making sure that your asymptote ends up in the right place. But this one's going to anyway. So just something to kind of keep in mind when you're doing these things that you need to pay attention to. So hopefully this kind of helps with creating the equations from the graphs themselves.